in this stack class, we are simply going to assert that it is not null. And what we're looking for is that the stack variable is not null. Now you can see we've got a couple of red squigglies here. Red squigglies bad. Green good, red bad. Red squiggly, that's a technical term. It means that Eclipse does not know what you're talking about when you say test. So the code generation tool tells us here that the JUnit library reference has not been made. That's why we're getting the red squiggly under test. So we're going to go ahead and add that reference, and the red squiggly under test goes away. Then we have a red squiggly here for the stack class, telling us that the stack class does not yet exist. So we're going to tell it to create the stack class. Just accept the defaults there. And now we have a class called stack, but our stack test, let's get rid of these extra ones here. Our stack test is still not complete because it does not know what an assertion is. So the code generation tool tells us that we should add a import for the org.junit assert. So we'll do that, and that makes those red squigglies go away. And at this point, we should have enough code in our minimal project structure to pass this existence test. Save our files. And we get 1 of 1 test passing. So that was a very basic structural test just to make sure that the basics of our stack utility exist. All that really means is that our stack.java, our stack class over here exists, but has nothing in it. So it's still completely useless, but at least it exists. So let's take this a step further. Add another test attribute. Create another test, public void. This time we're going to do an IsEmpty test. And in this test, we'll make sure the IsEmpty method exists and functions as expected. So again, we're going to create a new instance of the stack class. Stack equals new stack. And here, we'll do an assert true. And in our assert true, we will make sure that calling stack.isEmpty actually returns true. Now the problem that we're having here is that we have red squigglies telling us that the IsEmpty method does not exist. So we're going to use the code generation tools again to create the method IsEmpty. Now if we go, it takes us over here to our stack.java and tells us that it has created a public boolean IsEmpty that returns false. Now if we run this after our save, we get our test stack testing for the existence of the stack class passes just fine, but our IsEmpty test fails because our IsEmpty always returns false. Now, according to the TDD rhythm, what we're supposed to do now is write just enough code to make the test pass. Let's talk about that for a moment. If we write just enough code to make this test pass, the minimal amount of code to make this test pass would be just to return true. So I'm going to go ahead and do that just to illustrate the TDD rhythm here, writing just enough code to see this test pass. However, when I first saw this, it seemed like a waste of my time. If I know all I have to do is return the value from the IsEmpty method with 1 line of code, I'm thinking it's best to just do that. However, this TDD rhythm that says write just enough code to see the test pass is not intended for a simple Boolean method that returns a single value based on a method call. Imagine, if you will, a more complex method that retrieves values from multiple locations. Say, for example, for some reason, the database administrator, database designer, put all parts of a phone number in separate tables. You've got the area code in one table, the prefix in another table, and the suffix in another table. I can't think of any reason why you'd want to do that, but work with me for the demo here. So if we have all these pieces of the phone number in different locations, and maybe we have to call web services or different functions to get those different pieces of the phone number, and it's been stated in the acceptance criteria that the area code be wrapped in parentheses, followed by a space, and then the three-letter or three-digit prefix, followed by a hyphen, and then the four-digit suffix, the part of the TDD rhythm here that says write just enough code to pass the test is there so that we can figure out that formatting. And so for that method, what we might do is put a literal string out there with the area code wrapped in parentheses, followed by a space, and the three-letter prefix, and the hyphen, the four-digit suffix, and see if we pass the test. Once we've passed the test, then we know what that formatting is supposed to look like. Much easier to deal with figuring out the formatting by just hard coding the value and then seeing, oh, that's what it takes to pass the test. Now that we've passed the test, then we can go back and do the complex implementation where we get the area code from one table, the prefix from another table, and the suffix from another table. So the idea behind this portion of the TDD rhythm that says write just enough code to pass the test is we don't want to get all caught up with the implementation of the method while trying to pass the test. We want to understand what the test is getting at. So we write just enough code to pass the test so we understand the formatting requirements. Then we can go back and write the complex code to pull the data out of the database. So that's why this is here, and that's why when I do the write just enough code to pass the test in this demo with one line of code, it seems like a waste of time. But I'm going to go ahead and do it anyway just to drive the point home that the TDD rhythm is there to help you successfully implement test-driven development without too much overhead and too much confusion with what the acceptance criteria is looking for. So let's go ahead and do this. So, Dagnabbit. Gotta tape that cable down. So to that end, in our method here, we are going to simply return true. Now, obviously, returning true in this scenario will pass the test that we have now, but as we move further into our demo where we expect IsEmpty to return false, this test will fail miserably. So let's go ahead and run it after our save. We see that we have 2 of 2 tests passing. Now, I'm going to leave that like that for now until we get to a point where it's obvious that that test or that method is not doing what it's supposed to do. But for now, we'll continue on with writing the test for additional methods. The next method that we're going to implement is going to be the push method. So if we go back to our test, in our test we'll do public void push test. And in our push test, we are simply going to check and see if we can push a value into our stack using its push method. So stack equals new stack. And then we have our expected value as a string, which we'll set equal to hello world, because you can't have a programming demo without at least one hello world. And then our string actual will be set equal to the execution of our push method. Stack push, and into stack push we will push our expected value in the hopes that we will get back the actual value that's the same as our expected. And here we're going to do an assert equals. And we expect that our expected value is the same as our actual value. Now we have a red squiggly here implying that our push method does not exist. So we use our code generation tools to create the push method in our stack class. And you can see here that our push method was created for us, returning a string, expecting a string, but returning null. And if we run that test to see it fail, after saving, we see now that we have 2 tests passing and 1 test failing because null is not what we were expecting to be returned from that method. And actually, the reality is that this push method is not going to return a string. It's actually going to return a Boolean the first time around. So let's go ahead and start by fixing our push method. So our test fails. We're going to write just enough code to pass our test. First thing that we're going to do is include an array list of type string in our stack class, and we'll call it stack. And we're going to set that equal to a new instance of the array list of type string in our class. Now it's telling me that array list doesn't exist, so do we want to import the java.util namespace so that we can get that array list? Yes, we do, and now our red squigglies go away. So now that we have that, we can actually add values to our stack. So let's do that. We are going to do stack.add, and we're going to add our expected string. Now our add method returns a Boolean, not a string. So we could do this, return our Boolean, change the method to return a Boolean. Then of course we'll have to go back to our stack test to tell it to not do an assert equals, but rather an assert true, in which case we only want the actual value back. We have to make this a Boolean. Now everybody's happy. Run that test, and we should see it pass. Let's see. Our assertion failed. Let's double check that method. Oh, got an extra semicolon. I missed that red squiggly. Let's run it again. There we go. We've got 3 tests of 3 passing. Now, this is where it should get interesting. At this point, we have a set of passing tests that are passing because, number 1, the class exists. Number 2, the push method exists. And when we add something to the stack, the push method works successfully. But At this point, if we were to call the IsEmpty method, it would fail because the stack is no longer empty. So we're going to create a test to fill that gap in our testing process. So we're basically going to copy this push test, and we're going to call it push IsEmpty test. And what we're going to do here is the same thing that we did before. We're going to push into the stack, and then we're going to check and see if the stack is empty. So we're just going to move this call to the push method up on its own line. And then our Boolean result, we're going to call stack.isEmpty. And then we'll go ahead and run that. Oops. Actually, in this case, it should be assert false because we don't want the stack to be empty. I was wondering why that test passed. Let's run it again. So now we have 3 of 4 tests passing because as we push a value into the stack, we want the stack to be empty. But the stack is still returning true when we call the IsEmpty method. And that's because we wrote just enough code to pass the tests by returning true from our IsEmpty method. So now we can refactor that test according to our TDD rhythm. We wrote a failing test, we ran it to see it fail, we wrote just enough code to see it pass, we ran it to see it pass, and now we're going to refactor as needed to make sure that all of our tests pass. So we'll go back here, and instead of returning true, what we're going to return is this .stack .isEmpty. And that should be just enough to get our test to pass. Now we have 4 of 4 passing tests. So, what we've just illustrated here is that following the TDD rhythm, if you write just enough code to pass the test, the minimal, absolute minimal amount of code necessary to pass the first test that you write, you may end up coming back to that test later on after you've discovered that you need more code to make that test pass after you've run compound tests or other tests with that test. All right, in this case, the returning true from our IsEmpty method over here was sufficient when the only test that we had was testing to see if IsEmpty returned true. Once we got to a point where we were testing to see if IsEmpty returned false after pushing a value onto the stack, that minimal amount of code was no longer sufficient for passing all of our tests. So we went back and we refactored the test to actually have it check the stack to see if the stack was empty instead of just returning true. All right, so let's continue. We go back to our test project. We've got our IsEmpty method, we've got our push method, and we've got our push IsEmpty test method here. Now let's see if we can get the values off of our stack after we push them on. So we're going to create a public, less typing, less typos, void, and we're going to do a push peak test. And in this test method, we are going to push a value onto our stack. And see if we can peek at that value without taking it off of the stack. So we're going to do that by, again, setting something into the stack. And we'll just copy our code over here, because less typing means less typos. Copy that down here. So we're going to create the new stack, set our expected value, and then we're going to push a value onto the stack. And then instead of calling IsEmpty, we're going to call peak. And here what we expect is that the values are equal. So we're going to do an assert equals, where we expect that the expected value is equal to the actual value. But again, we have red squigglies telling us that we have not yet created the peak method. So we're going to create the peak method in the stack class. And we get a public string peak that returns a null. And if we follow the TDD rhythm, we write a failing test. We run the test, we see it fail. So we have minimal project structure. We can run our test and see it fail. But what we really want to do here is get from our stack that first value that we just added in. So we're going to do stack.get. And the value that we're going to get is that first value off the top, which is index 0. And now we should be able to run our test and see it pass. So now we have 4 of 4 tests passing. Next thing that we want to do here is pop. Now, as is the case with the stack, we should be able to peek at the value on the stack, and then we should be able to still view that value on the stack because it has not yet been removed. So I suppose to verify that, we could write a test that's almost an exact duplicate of the test that we just wrote. And I will call this one push peak peak. Essentially illustrating that we can call the peak method twice, and we should still get the same value back. So the first time I call peak, I'm not going to store the value in a variable. Second time I call peak, I expect to get the same value that I got the first time. So I'll run that, see it pass, just to verify that our peak method is doing what it's supposed to do. And again, 6 of 6 tests passing, so all of our tests are passing successfully. So let's move on to pop. Again, I'm going to copy the code here. Oops. And we'll do a push pop test. And here, pretty much everything the same except for we're going to call the pop method. And we still expect to get equal values. So we're going to create the pop method in the stack class. And there we've got our pop method returning a null. Run the test, see it fail. And there we have our 1 failing test. 7 tests, or 6 tests passing, 1 test failing. And now what we want to do for pop is create a variable, string result. Set that variable equal to stack get. And then we want to remove the value at index 0. And then return our result. And that should give us a passing test. Now we have 7 of 7 tests passing. But is it really gone? So to ensure that we're getting the results that we're expecting, we are going to copy this test and paste it. And we're going to call it push pop is empty test. And same as before, we're going to do our push, we're going to do our pop, but instead of checking the value that we get back, because we know we're getting back the correct value because we have a test for that, we're going to do a push pop, and then we're going to call the stack dot IsEmpty method, and we expect that we'll get a true. So here we'll create a Boolean, and we'll call that result as well, and set that equal to calling that method. And here we expect that it should be true after we pop the value off. And now we'll run that test. Now, notice this dialog box keeps coming up. I left it there on purpose so you can see that we're given an opportunity to save every time we make a change, but that's starting to annoy me now, so I'm going to check this checkbox to always save resources before launching. And now we have 8 of 8 tests passing, so we know that when we push a value onto the stack and we pop the value off of the stack, that value is no longer there because our stack is now empty. Now, we've got push, we've got pop, we've got peek. But let's see what happens if we push multiple values onto the stack and try to retrieve them with pop. So we'll call this test, what's a good name for this test? Why don't we call it multi-push pop? Public void, multi push pop. And again, basically the same test that we have here for our push pop test. So I'm going to copy this code down here. But instead of just one push, we're going to do multiple push. So I'm going to copy this expected value. Call the second one expected 2. And we'll say, goodbye, cruel world. All right. So we expect then that the expected 2, when we push that, will be at the top of the stack. Therefore, when we push, we would expect that our actual value is equal to our second expected value. Let's run that. Wah, wah, wah. We do not get a successful test. And that's because the way that we're pushing the items onto the array list by default is a what is it? A FIFO. So first in, first out. And what we really want is a LIFO. We want a last in, first out. So we have to manipulate the array list to make sure the items that we're adding them to the top of the stack. So if we go over here, where we're doing our stack.add, and we do a stack.add and we give it an index, we tell it that we want to add the value at index 0, that method no longer returns a result. So we'll have to move this up here and simply return true to keep our test passing. Now we're adding each value at the top of the stack as opposed to the default of the array list, which is adding it to the bottom of the stack. If we run our test again, our multi-push pop should pass this time. Now we have 9 of 9 results, 9 of 9 tests passing. And I think, except for some minor refactoring, that concludes our series of tests. So let's go back and do a little refactoring because it gets tedious creating this new instance of the stack every single time. So we are going to create a before method at before. And in our before method, public void, we'll call it setup. We are going to set up this new stack class. First, we are going to create a class level variable called stack, semicolon. And then in our setup, we are going to say stack equals new stack. Oops. Now, essentially what this is doing for us is every time before a test runs, it's going to run this before method. So that means we can exclude the stack equals new stack from every one of our test methods. But we're getting a little red squiggly here, which is telling us that we have not imported the JUnit, the org.junit namespace where before is included. So let's go ahead and import that. Now our red squiggly goes away. And now we can simply go to each one of these methods and delete the line where we create a new instance of the stack class. Delete. 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 And delete. Oh, one more. Okay, lots more. So we delete all these extra lines of code to create a new instance of the stack. We're a little more efficient here. Less typing, less typos, because that is now included in our setup method. So run it again, make sure everything is still passing. And there we go. 9 of 9 tests passing. Our stack class is complete. So in this demo, in Eclipse Oxygen, latest version of Eclipse came out in June, we followed the TDD rhythm by first writing a failing test and then writing just enough code to run that test and see that test fail. That just enough code is what we call minimal project structure. Just enough code so that the classes and the projects exist so we can compile, but not enough code that we can actually write and run actual tests. Then we wrote additional failing tests for the actual method implementations. We ran those tests, saw them fail. We wrote just enough code to see them pass. And then we refactored those tests and those methods so that we got the actual implementation that was required to meet the acceptance criteria set forth by our customer. So that includes this Java TDD demo. If you're interested in how we do this in C#, stay tuned for the next demo.